This lesson is on graphing systems of equations or solving systems of equations graphically. So the first example is solve this system of linear equations by graphing. Well, to do that, first we need to make sure both of our equations are in slope-intercept form. This is, so that's good. We're going to hold on to that, but we need to first put the second one in slope-intercept form. So I'm going to subtract 2x from both sides. Y equals, I cannot combine a negative 2x and a 4, so just minus 2x plus 4. Now both of my equations are in slope-intercept form. What I'm going to do is graph them. You can do it by hand, just like so. Start at negative 3 for my first line. I'm going to follow my slope. Goes rise 1, right 3, or down 1, left 3. That is the first line. And then my second line says to start at positive 4 on the y-axis. 1, 2, 3, 4. And I'm following a slope of negative 2, which is just negative 2 over 1. So down 2, right 1, down 2, right 1, down 2, right 1, and you can keep going. So now, the solution to my system of equations, the system being the two lines, the solution is where the point where they intersect. Well, they intersect at 1, 2, 3, negative 2. That is the answer. It is a solution to this system of equations. That means this x and y make both equations true. And you could plug them in to check. That is one solution because there is one point where they cross. Example 2. Again, solve it by putting it into this graph. So I have to solve for y. I'm going to subtract 2x. Y equals negative 2x minus 1. And then got to do the same thing for the next one. I'm going to have to add 15. Got to get rid of that because I'm getting y by itself. So 3y equals 3x plus 15. My last step is to divide by 3. Y equals x plus 5. So let's graph our lines. Start at negative 1. I'm going down to right 1 because it's over 1, or up to left 1. Connect your dots. Graph your second line. Start at positive 5. And I'm going, there's no slope here, so it's like an invisible 1 over 1. So I could go up 1, right 1, or down 1, left 1, down 1, left 1, continuously. The solution, or the point they intersect, is at negative 2, 3. Left 2, and then up 3. The way to do this in a graphing calculator would be to put in to the y equals your two equations, negative 2x minus 1 and x plus 5 in y1 and y2. And then you're going to hit second, trace, and we want to see where it intersects. So number 5, and then enter 3 times. 1, 2, 3. It has to say intersection, and it's at negative 2, 3, which is exactly what we got. And you can check it in the first one as well. Putting them in y in that slope-intercept form. 1/3 x minus 3. And the second equation was negative 2x plus 4. Second, trace, there it is, can't see it, sorry, 5, and, Okay, so we're going to hold on, wait till it finishes graphing. That's what our graph should look like. And then you can't go by this number. You have to hit second, trace, 5, enter, enter, enter. It has to say intersection, and it is at 3, -2. Good. So then let's look at an example with no solution. Well, let's solve for y in the second equation by subtracting 3x. Y equals -3x minus 4. Here's one equation, and here's the second. You can go ahead and graph them on your paper or in your calculator, but make sure you definitely have it here too. Up at +2, down 3, right 1, down 3, right 1. And then the second one is at -4. You can't go down 3 and left 1, so we're going to go up 3, left 1, up 3, left 1, up 3, left 1. These lines are parallel. Parallel lines have no solution because they do not cross. There is no point of intersection. We know that these are parallel when there is the same slope and different y-intercepts. Okay? And then let's try an example with infinitely many solutions. Same beginning part. I have to have my equations in slope-intercept form. So add x to y equals x minus 2. Divide by 2. Y equals 1/2 x minus 1. And then here, the only thing I have to do is divide by 4. Y equals 1/2 x minus 1. Well, if you'll notice, they're exactly the same line. So I could start at -1, follow the slope. Here's the first line, but they're exactly the same. So I would end up putting this second line right on top of it. That means that every point is the same. This is called infinitely many solutions because every single ordered pair would work. This is when they have the same slope and same y-intercept because it is the same line. And that is the lesson for solving systems by graphing.